Next question, question 5. And now I am going to discuss some good questions. As far as 1, 2, 3, 4 are concerned, as you are seeing, these are good questions, but as far as transferring is concerned, as far as charge addition is concerned, distance calculation in centimeter and meter conversion is concerned, are good questions. But as far as myself is concerned, you know very well that what the mean of good question for me. For me, the good question means good question. Question 5. An infinite dielectric sheet having charge density small sigma has a hole of radius r in it. An electron is released on the axis of the hole a distance under root 3r from the center. Find its velocity and acceleration when it reaches to the center of the hole. Figure is as you are seeing in the figure. Take 5 minutes and try your best. Here in this question, in question 5, an infinite sheet is present which have a circular cavity and the charge density on the plate is a small sigma. The radius of this hole is r, and on the axis of this hole at distance root 3r, an electron is present. When this electron is released, then electron have negative charge and the plate have positive charge. So this electron must attracted by the sheet. So it moves along the axis. When the electron reaches to this point, what is the acceleration when electron reaches to this point? What is the velocity and acceleration that is required? So for a sheet, you know very well that E is equal to a small sigma upon 2x pi. As far as disk is concerned, the electric field on the disk at the axis is, suppose this is a disk which have a small sigma charge density, then on the axis of this disk here if this distance is x, then at this point E will be a small sigma upon 2 epsilon naught in bracket 1 minus x by under root x square plus r square. From where this comes? I will prove just after solving this question. This result you should have to learn. Must have to learn. So the net electric field at this point will be equal to, this is due to sheet and this is due to cavity. So E net can be calculated as is E1 minus E2 is equal to small sigma upon 2 epsilon naught, take as common 1 minus 1 plus x upon under root x square plus r square. So will become small sigma x by 2 epsilon naught in under root x square plus r square. Okay. So if you put the value x here, you will get E net is equal to a small sigma x by 2 epsilon naught under root x square plus r square. If this is the force, if force is to be calculated, then F is equal to QE. Here Q is negative E and E net is this. So if you multiply here with minus E, you can get F net. This F net can be, F is equal to MA. MA can be written as M V dV by dx. So as far as acceleration is concerned, when x is equal to 0, acceleration will be 0. So at the center, acceleration must be equal to 0. At center of hole, acceleration will be 0 as x is equal to 0. Clear? Very clear. As far as velocity is concerned, this dx comes here. So you can write it as v dv, initial velocity 0, final velocity v, is equal to limit is root 3r to 0 is small sigma x minus e divided by 2 epsilon naught m under root x square plus r square dx. This will become v square by 2 this negative sign accumulate the limit, and limit will be 0 root 3 r e small sigma x dx by 2 epsilon naught m under root x square plus r square. When you solve it, you can get only r. Thus, you will E small sigma r by 2 epsilon naught m. 2 will cancel out. Thus, V is equal to under root small sigma r e by m epsilon naught. This will be the answer. You can say, sir, how you calculate it? That is too much easy. You can put here x square plus r square is equal to t. Then 2x dx is equal to dt. For limit, when x is equal to under root 3r means 3r square plus r square. So t will become 4r square. 4r square. And when the x is 0, then t can be written as r square. And x dx can be written as dt by 2, dt by 2, 1 by 2, and this can be written as 1 by root t is equal to 1 by 2, 1 by root 2. 1 by root 2 integration t की power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. So under root t by 1 by 2. So 2 under root t. So 2 under root t. Upper limit 4r square. Lower limit r square. These two will cancel out, and by applying 4r square here you will get 2r, and by this lower limit r square you will get here r. So 2r minus r, and thus you can get r. Okay. So the final answer, velocity will be equal to answer is A is equal to 0 and V is equal to under root a small sigma R E by M epsilon naught. Okay? And now see from where this relation comes. Okay. As I use the formula for a disk as a small sigma upon 2 epsilon naught in bracket 1 minus x upon under root r square plus x square. From where this comes? All of you know that for a sheet which have a charge density small sigma have electric field near is equal to a small sigma upon 2 epsilon naught. You know very well this can be easily proved by Gauss theorem. If you put a cylinder in this sheet, if this is the cylinder you put here, if this is the cylinder, then the flux crosses this and the flux crosses backward is as this. If the area is A, cross section area is A, then the flux due to this surface E dot A have direction along the electric field, because if this have a positive charge density, then this must have a electric field lines outward, and direction of this area is again along the electric field. So E dot A can be written as EA. Here electric field lines are backward and the cross section area direction is again backward. So E dot A again it is second flux is equal to EA again, and this flux due to first cross section surface is again EA, and the flux due to this curved area, because it has 90 degree in area and electric field direction, so it has is equal to 0. So net flux will be phi 1 plus phi 2 plus phi 3 is equal to 2EA. By Gauss theorem, you know very well that closed integral E dot A is equal to Q upon epsilon naught. And enclosed charge, if the small sigma is the charge density, then QA is equal to small sigma A upon epsilon naught, which must be equal to 2EA. This gives you E is equal to small sigma upon 2 epsilon naught. I know that you know this very well. Okay. Now, the electric field due to a ring which have radius r along the axis at this point, electric field will be equal to K Q X upon under root R square plus X square. In fact, it is not root but power 3 by 2. That is correct. Okay. How you can prove this? You can prove it again very easily. Take a small segment here as dq. Then due to this dq, an electric field will be in this direction. So this will be dE. So along the axis, electric field will be equal to dE cos theta, dE net. If you integrate here, you must have to integrate here also. And the perpendicular component, this one, will cancel out by the small segment dq which have electric field in this direction. So, if this angle is alpha, then this must be alpha, and due to symmetry it is again alpha. This must be alpha. So dE sin alpha and dE sin alpha both will cancel out each other, and only dE cos theta remain. Okay. So if you integrate the whole, you can get here K Q by, if this one is R, small r, and for cos theta it is x upon r, that is x upon r. R can be written as under root R square plus X square. Electric field formula is KQ upon R square. Potential is KQ upon R. Okay. So you must get here E is equal to KQ by R cube X. In turn you can write it as KQX upon R square plus X square power 3 by 2. I know very well that you know this also. You know very well. Now, you have to find the electric field due to a disk which have uniform charge density small sigma. If you have this disk and in this disk you have a small sigma charge density, then at point X on the axis what it have electric field. As I use in the question is a small sigma upon 2 epsilon naught in bracket 1 minus x upon under root r square plus x square. I use this. From where this comes? By using this comes. Let's see how. Take a small segment element here. This is the small segment. And if this small segment have net charge dq, then this dq must be equal to the radius at this point is y, then this dq is a small sigma 2 pi y and dy. dy is the depth. Circumference is 2 pi y and the surface density is a small sigma per unit area. Okay. So due to this charge at this point, electric field will be dE is equal to apply this. So K dq x upon r square plus x square power 3 by 2. Okay. Now you have to put in place of r y. Now it will be the electric field by this small segment of charge dq. This charge is dq. Okay. Now you have to put the value of dq here. The value of dq here, and you will get dE is equal to K. K means 1 upon 4 pi epsilon naught dq is small sigma 2 pi y dy x upon y square plus x square 3 by 2. Here x is constant and y is variable. Okay. Now if you integrate this electric field from 0 to r, then you will get the net electric field due to a disk at this point which is on the axis at x distance. Okay. 2 pi will cancel out. So you can write it as a small sigma x upon 2 epsilon naught integral 0 to r y dy upon y square plus x square power 3 by 2. No problem. You can see it very well. Now, if you put y square plus x square as t, y square plus x square as t, then you will get E net is equal to integral. If you put here in place of y0, you will get t is equal to x square. So here you have to put x square. If you put here y, then you will get in place of t r square plus x square. Of course, small sigma x upon 2 epsilon naught. Of course, small sigma x upon 2 epsilon naught before the integral as constant or as common, you can say. Okay. To put it some clarity more, is equal to a small sigma x upon 2 epsilon naught integral x square r square plus x square. For differentiation, you will get here, because x is constant, 2y dy is equal to dt. So you can put here in place of y dy dt by t, dt by 2, and in place of y square plus x square, t power 3 by 2 is equal to a small sigma x upon 2 epsilon naught, and the integral will become 1 by 2, this 1 by 2, t की power minus 3 by 2 plus 1 means minus 1 by 2 in power, and in dividation also minus 1 by 2. So 1 by root t and negative 1 by 2. Write it more clearly as root t minus 1 by 2 in multiplication. So 2 will cancel out. Upper limit r square plus x square, lower limit x square. So this can be written as a small sigma x upon 2 epsilon naught in bracket minus 1 by root r square plus x square. Take this minus as common. So take this minus here, minus 1 by, for x square, it will become x. So this minus will give here, if you remove this minus, you will get a minus sign here and a plus sign here. Now if you multiply this x here, you will get inside x, remove this x, and thus you will get x here and x here. X divided by x will cancel out and will become 1. So you can write it as 1. Now the result is nothing but the same as I have written. Okay. So as far as your learning is concerned, you must have to learn this. You must have to learn this. And you must have to learn this also. You must have to learn this also. Whenever the situation, whenever the question require, you directly put these formula as I put in the question. Okay.